Hello, my name is Ryan from Buster Beagle 3D, and today I'm going to be reviewing the IKIER K1 Pro Max 70-watt laser diode cutting and engraving machine. At 70-watt output power, this is the most powerful machine I have tested to date. I will be reviewing the combo version that comes with an air assist as well as this enclosure. So what do I think of this machine? Does bigger and more powerful always mean better? Well, let's find out. First, as usual, I wanted to thank IKIER for providing me with this machine for my honest review. There are affiliate links in the description that do help out the channel if you decide this machine is for you after hearing what I have to say about it, but as always, it doesn't influence what I have to say about the machine. With that out of the way, let's get started. If you are not familiar with IKIER, it's supposed to be the high-end brand under the Atom Stack brand. Out of all of my lasers, I didn't have an Atom Stack machine, so I can't compare the quality difference, but it does seem to be a very nice quality. I'll be reviewing this setup as a combo of the laser with this enclosure. You can purchase this laser separate from the enclosure if you wish, but I find the enclosure to be such an important safety feature that I'm really only trying to review machines where this is an option. So first I will talk about the laser portion, as it comes mostly assembled where you just have to attach the gantry to the frame and then add the laser module onto the gantry and plug everything in. Right off the bat, the most obvious thing you will notice about the laser module is the size of it. At 70 watts, this is not only my most powerful laser I now have, it's also the largest diode laser that I have. Here you can see it next to many of my other diode modules. Right next to it is my 40-watt laser, and then a 20-watt, 10-watt, and finally a 5-watt. You can see just how massive this module is next to those others. It achieves its 70 watts of power output by combining 14 different 6-watt diodes into one. I know that equals 77 watts, but they're probably accounting for the slight loss of power in the combining process. Many times you will see different machines saying that they are 80 watts, but that was a little bit of a deceptive practice many brands use when these companies were telling the machine power and not the laser output power. On this machine, 70 watts is the output power, so that is what you get coming out of the laser module itself. There is also a switch on the side of the laser to essentially turn half of the diodes off, thus giving you the 35-watt laser. Now, why would you ever want to lower the power of the laser? Well, that all has to do with the spot size of the laser. Typically, the higher the wattage of the laser, the larger the spot size. This has to do with the combination of all those separate beams into one. The 70-watt version of the laser has a spot size of 0.15 millimeters by 0.2 millimeters. The spot size of the 35-watt laser is smaller at 0.1 millimeters by 0.15 millimeters. Not a big difference between those two, but it would be a big difference between something like a single 5-watt laser versus this machine. A lower 5-watt module could engrave at a much higher resolution than a machine like this. I always like to compare that to Sharpie markers, where you can get a finer point with a finer tip versus a regular tip marker. The same concept applies here. So with that switch turned on to the 35-watt size, you can get up to a resolution of 169 dpi, whereas with something like a 5-watt laser, you can get closer to a 318 dpi or higher. This machine module also comes with a few other notable features. First is the integrated air assist that is very important while cutting. There is a variable flow rate air pump that also comes with the machine to feed the air assist. This is also controllable through the software like Lightburn, where the air can be turned off or on per layer. Next to the air assist nozzle is a laser crosshair pointer that could allow you to use it as an offset aligning tool to find your laser position, or simply use to make sure your workpieces are square to the laser. I personally would suggest not setting it as an offset of your laser, and always use the laser spot itself as a framing tool, since it will give you the most accurate results. The last and most potentially impressive feature of this laser module, other than its power, is the autofocus feature of this machine. With the touch of the button on the machine itself, or by setting up a macro button in the software, you can tell the laser to probe the surface you are working on and set the proper engraving height. The surface does need to be pretty flat, but it's a great way to get everything set up pretty quickly. As far as I can tell, this only applies to the engraving height. The cutting height will have to be set with the fixed focus block that comes with the machine. This brings me to the first thing I think could be improved with this machine, and that is the documentation and instructions that come with this machine. As far as I could find, there are no mentions of this fixed focus block anywhere in the user manual. The way it works is pretty self-explanatory if you're used to working with lasers, but for those who are not, you need to place this between the laser body and the part you are working on. If you are only engraving, the laser should rest on the top of this block. This should match the same distance you get when you use that button to focus your laser. If you're going to be cutting, you need to make sure your laser module rests on the middle block for thicknesses under 20 millimeters and on the bottom step for over 20 millimeters thick. Again, this is not hard for those who have used lasers before, but I couldn't find anything about it in the user manual. Now, this also could be because the user manual has very tiny print. Even with my 20/20 vision, it was difficult to see anything in that manual since the print is so tiny. I would recommend checking out the digital files on the USB stick that comes with the laser that has all the manuals. Another cool feature of the Z-axis motor for focusing is that you could set the height to adjust automatically while cutting. That means that if you were cutting a particularly thick part with multiple passes, you could set the motor to lower the laser head after each pass for an even deeper cut. Other features of the laser machine itself is an all-metal frame that feels very sturdy. The X-axis runs on linear rails, while the Y-axis runs on two thick steel rods. It needs it for the additional weight of the laser module and has a top speed of 54,000 millimeters per minute. That's really fast for a diode machine. I even ran some tests at 50,000 millimeters per minute, and it really actually did a pretty good job, which I'll talk about in a minute. The workable area of the machine is 410 millimeters by 410 millimeters, and for my test, it can reach the full workable area that the company claims. On the front of the machine, there is a box with all of the brains of the machine. It's where everything plugs in and contains the power button, the autofocus button that I talked about before, a USB port for online engraving, an alarm light, and a safety feature of a key that needs to be turned on to use the machine to keep those who are not supposed to be using it from using the laser. Other safety features include flame detection, tilt detection in case the machine falls off the table, and on this combo machine, open door detection where the machine will pause if the lid is opened in the middle of a job and resume only after it's closed. One major tip I wanted to give you here is you really need to make sure that the lid is closed before trying to run anything on the laser, including the setup. If you try to add the device in Lightburn, make sure the lid is closed or it will have trouble finding it. You also want to make sure it's closed before you home or really anything else with the machine. I also wanted to point out something else that seems to be missing in the user manual, and it is that you need to plug in the wires from the enclosure to the bottom of the laser if you want to enable that door function. If you do not plug in those wires, the open door safety function will be disabled. On the front of the machine is a really nice touchscreen. It's connected by an HDMI cable and sticks to the front of the control panel with magnets. It's from here that you can run those offline jobs from a USB stick, which is really nice in case you can't have the laser near your computer. And speaking of that, if you're going to want to connect this to your computer, you may want to pick up a longer USB-C to regular USB cable. The one that comes with it is pretty short at around 3.5 feet, so unless your computer is right next to it or you're running it from a laptop, you're probably going to need a longer cord like I did. You can also adjust some settings such as turning off the fire detection and tilt sensors if you prefer in the touchscreen UI, but the main function here would be running offline jobs. The K1 Max Pro can be controlled by Lightburn like I mentioned before, or free programs like LaserGurble. Lightburn is my personal favorite, so that is what I use for all of my testing. The machine can also be controlled by a cell phone, but there's almost no mention of it anywhere in the manual or on the website. The machine does have a Wi-Fi antenna, but again, there's no mention of Wi-Fi capabilities with this machine. I did, however, download the IKIER app and was able to connect to the machine directly as a Wi-Fi hotspot, but the app was pretty clunky and really only gave me many of the abilities that the touchscreen would, so I'm not sure how you would use it. It's really not fleshed out much, but since it's there, I hope the Wi-Fi capabilities are going to be incorporated more in the machine in the future. Now, before I get into the results that I got with this laser, I wanted to talk a little bit about the enclosure for this machine. While the laser itself is fairly assembled straight out of the box, that is not the case at all with the enclosure. You do have to assemble the enclosure and screw all the panels in place. It's not a super hard job, but it will take you some time to get the whole thing put together. The enclosure itself is made out of a powder-coated steel and has very nice orange laser safety acrylic panels to see what is going on with your laser. There is also a camera mounted onto the top of the enclosure, so you can use that to set up your work in Lightburn. Mounted on each side are two very nice lights, so you can see what's going on with the machine inside. The fan mounted on the back left helps to extract the smoke out of the enclosure, which you should vent outdoors or to an air purifier. You essentially have to assemble the back of the enclosure, and then you're going to need to install the laser where it will mount to the frame of the enclosure itself. This keeps the laser static and attached, which is necessary because the front electronics of the laser stick out of the hole in the front of the enclosure, and you don't want your laser frame to move after you calibrate your camera. I wanted to mention something else here, and it's an issue I've had with other enclosures in the past, and that is that it does not come with a bottom to the enclosure. It is meant to be placed directly on the table or a workbench, creating a bottom to the enclosure. I have a problem with that for two reasons. The first and most obvious reason is that I want my table or whatever surface to be protected from the laser, so the bottom would have been nice for that reason alone. Sure, you can use a protective honeycomb or working panels, which I'll talk about in a minute, but mostly I wanted to make sure that I'm not marking on my table. The second big reason, and this might not have been obvious when I was talking about the working area, but this machine is pretty long. To be able to have this machine and still have the workable area of 410 by 410 millimeters, it needs to take into account the around 150 millimeters or 6 inches of space the laser module and the gantry take up. This makes this laser one of the longest lasers that I have. From front to back, the laser enclosure is 730 millimeters or around 29 inches. Well, my table is only 2 feet deep, and so I'm short about 5 inches. In fact, in my home, the only table wide enough to hold it was my dining room table, and I don't think that would fly with my wife. All of this is really to say that I needed a floor to the enclosure so I could sit it on a shorter table and hang off without exposing the front and the back of the machine, letting the smoke and fumes escape. So I went to my lumber store and bought a 29 by 29 inch piece of 1/2 inch plywood to place under the machine. This not only gave me a nice base for the machine to sit on, it also enclosed it fully to help with the smoke and fumes. Again, I really think that an enclosure is an essential part of using one of these machines, especially one as powerful as this K1 Pro Max 70 watt. However, there are a few things that I think could be improved on. I already talked about the fact that I wish it had a floor. The second issue I had was that I felt that the enclosure could have used some weather stripping to really seal up the box a little bit better. While I'm using the machine, you can clearly see many areas where I have laser light leaking from the enclosure. There are gaps around the front door, as well as large gaps around the electronics box. This makes for a less than sealed box, which meant that I could still smell a fair amount of the smoke while the machine was operating. I might go and try to add some window weather stripping inside of these areas to help with that laser light and the smoke leaking. The second thing that I wish that I saw with such a powerful machine is a larger exhaust fan and hose. The hose that comes off of the laser is only 80 millimeters or 3 inches in diameter, which feels a bit small. To put that in perspective, the hose that came off of my 55-watt CO2 laser was 110 millimeters, or over 4 inches in diameter. I just felt that especially while cutting, it was harder for the smaller fan and hose to move the amount of smoke it needed to really clear the air efficiently. I even had the hose joined to an inline fan with lots of suction, but it didn't feel like it was clearing the air fast enough to keep the smoke from leaking out. 2 more quick notes about the enclosure before I move on, and that was that the fan that I'm talking about is always running when the machine is running. It's not something that can be turned on when the job is running. However, you can simply unplug it when you are not running a job, since the fan is a little bit loud and annoying when you have it on all the time. The last note is about the camera in the enclosure, and more specifically, the camera cord. When you open up the enclosure door, it will lean pretty far back to keep it from falling back down onto you, which is fine. The problem is that as you lean the door all of the way back, it pulls on the camera cord to reach around this hinge. When you go to close the door, that extra cord will now hang down below the camera. In my case, after it hung down, it now collided with the air assist hose coming off of the top of the module. It would have been better if the wire mounts didn't go straight back, but went across the hinge and then back on one of the sides of the machine where the laser module can't reach, thus never having the opportunity to collide with the laser hose. I know I just listed off a bunch of things that I think could be improved, but I also wanted to emphasize that if you're going to pick up one of these machines, I highly recommend picking up this or some other sort of enclosure for it. Most of what I mentioned can be adjusted with some small tweaks that would greatly improve the effectiveness of this enclosure. Another thing this enclosure adds to this laser is that camera that I just mentioned. It's a good way of being able to capture your work area and use that to place artwork directly on where your items need to go. You do have to calibrate your lens and your camera alignment in Lightburn to make sure you get this as close as possible. There are directions for how to do this in the manual, but that process is pretty standard across many different lasers, so there are videos on YouTube that go over this process as well. The issue that I have with the camera on essentially any laser engraver is really the fine accuracy. It will get you close, but if you need to be super accurate, I would still go with a grid over using the camera. The problem is that the camera and software have to work out different image skewing and project a full top-down image from a single point. While it's close, it can still be a little off, and sometimes that's just too far off. On top of that, you really need to change your camera alignment to account for the height of your workpiece. So if you ran the alignment on a 3mm thick piece of wood, that would no longer be correct for a 20mm thick piece of wood. You would have to change it for every height you are cutting or engraving at to be as accurate as possible. Even with my best efforts to calibrate the camera and alignment, I was still slightly off. Again, for cutting out of a material, this may be close enough, but it might not always be the case. My preferred method for alignment is, and always really will be, a grid burned onto a spoil board using absolute coordinates. So that's what I did. I created a grid for the full workable area of the machine and burned it onto a spoil board. That way, when I place artwork in Lightburn and choose absolute coordinates, I know exactly where it's going to show up on my workpiece. The other advantage is that I know that my workpieces are 100% square to my laser as well. I don't have to worry that everything is at a slight angle or use the laser crosshairs to figure out that my wood is straight. I just have to align it to my grid and everything ends up exactly where it's supposed to be. There are holes in the corners of the enclosure so that you just want to be sure to screw it down to the spoil board to make sure the grid is accurate every time. I'll have a link to this grid in the video description. With all of that out of the way, we can now go over how this machine performed. For all of the engraving that I'm showing, I was using the 35-watt switch, which again gives you a finer detail over the 70-watt switch, which I will be using for all of my cutting. I first started off with a long burn of this 3D flower image. I wanted to try something pretty conservative, so I burned this at 10,000 millimeters per minute at 25% power. It came out fine, and by using the grid, it really came out very straight on the board. It even came out nice at that lower resolution that I was talking about before because the larger spot size. You still get a good amount of detail, and I was satisfied with the results. The next thing I wanted to try out was the offline method of using this machine. With the handheld touchscreen, you are able to burn files without a computer hooked up directly. You simply need to save the file from Lightburn or your program of choice to a .gc or G-code file, and then you can load it directly on your machine. I ran this Marvel calendar I had uploaded onto the USB stick that came with the machine. I set the file up to run at 10,000 millimeters per minute at 40% power, and it again came out fine. Now, there are some settings on the touchscreen to change the mode of the laser from standard to fast and fine. I changed the mode to fast and ran the job again from the USB stick, but didn't really notice any change in the speed of the engraving. My guess is that it's changing the acceleration and movement speed of the laser, but not the actual engraving speed. This would only really give you a difference in speed when you were dealing with larger job with more white spaces that the laser has to jump over, and not something like this small calendar. 10,000 millimeters per minute is much slower than what this machine says it can work at, so I bumped it up to 30,000 millimeters per minute at 75% power, which, as you would imagine, worked about 3 times faster than the first 2 tries. It still came out very good and was somewhat crazy to see this huge laser module moving this fast. Well, this K1 Max Pro machine reports a top speed of 54,000 millimeters per minute, so I bumped it up to just under that at 50,000 millimeters per minute at 75% power and ran this job again. This time it was still burning, but was a little light. So what I did, and one of the things that you can do with the touchscreen, is that you can increase the speed or power while it's working. So right at the halfway point, I increased the laser power to full so that it would work darker. You can tell the bottom half is lighter than the top half. It's also not as deep as the engraving like it was on the 10 or 30,000 millimeters per minute, but it does have some depth. It's pretty impressive and really shows you not only how powerful this laser is, but how well built and sturdy it is to be able to run at those speeds with that weight of the laser diode. So I obviously knew that this machine could engrave, but what I really wanted to try out was the full 70-watt power of this laser while cutting. I started off small with some tests on some 3mm basswood, which of course I knew that it could cut, since a 5-watt laser could cut this, but what I wanted to know was how fast it could do it. After running a bunch of tests on my Buster logo, I fell on what I was comfortable with, which was 800 millimeters per minute at 100% power in one pass. It's the fastest I've cut wood with any of my lasers so far. I first cut out this tree pattern just to make sure that the machine would not have any issues with that power and speed. It did a good job, and the air assist really did a good job of keeping any charring of the wood to a minimum. Thinking back when I would cut these kind of things out with a 5 or 10 watt laser in the past, it's pretty insane to see how fast this is moving with this 70-watt module. Next, just for fun, I made this little treehouse out of a design I found online, and again, with the power of the 70-watt laser, you really can cut your time down exponentially over the lower power lasers. I knew this was going to work and be fast, but it's very satisfying to see just how fast it works. Next, I wanted to try something a bit thicker. I had this tree slice laying around, and I thought I would give it a go. I don't know the exact kind of wood, but my guess is some sort of pine. I first made a few little test holes to dial in my settings to find what I wanted to try to cut my design out. Now, while you could burn through this wood in one pass, I typically don't like to do that. I find that the slower and longer the laser is burning in one spot, the more likely you are to ignite the wood or potentially start an internal burning in the wood that ruins the part. I much prefer faster speeds but more passes. You still end up getting through the wood in the same time, but the laser is never spending too much time in one spot. So after my test, I came up with 1500 millimeters per minute at 100% power and 5 passes. It may have worked in less passes, but I let it go 5 just to make sure. It really did a nice job of cutting the love sign out. The other thing that I was really impressed by was how clean the sides of the wood were. Moving at 1500 millimeters per minute really gave me a clean cut. My wife, who saw me make this, already claimed it, so it's already being put to good use. Now, I know that sometimes you feel that if the laser is really powerful, then you should be able to cut deeper and deeper into wood, but to be honest, I would somewhat advise against it. Could you cut through a 2x4? Probably. Should you do that? Probably not. The right tool for the right job. The issue really comes into play with how deep and long the laser is in contact with the surface. What happens if you try to go too deep is that you may get the inside of the wood igniting and burning it internally while you are cutting. So while you probably could cut deeper, I would suggest keeping it to under an inch or about 25 millimeters. Okay, so I want to talk a little bit about the panel that you can get to go under for when you're cutting with this machine. Now, they suggest that you do get this version that has these teeth in it versus something like the honeycomb, because they claim that the honeycomb can leave burn marks on the back or kind of a pattern that might appear when you use something like a honeycomb versus something like this, where it's supposed to have less contact with the surface that you're working on. But I do have a couple issues with this particular design. The first thing is that it doesn't come assembled. You have to put this whole thing together, so it comes in pieces. And, while it's not super difficult to put together, I actually screwed up while I was doing it. And since all of these pieces have to put in separately, if you accidentally do something and, you separate the two sides out, then you just have to start over again. So I had to start over while I was assembling this. The other benefit that they say about this design versus something like a honeycomb is that this thing is already, it's just one piece. So there's nothing that goes underneath this, because the laser is not supposed to be able to get under this design. The problem with that, though, is they even give you a piece of paper. And the reason they're giving you this piece of paper is that there are air vents underneath this. And what happens is, as the smoke goes under, it can basically dirty the surface underneath where you're engraving. So if you have to put something underneath it anyway, like a piece of paper like they're providing, I don't really see the benefit of this over something like a honeycomb that would come with a metal plate that's underneath it. Now, the other kind of issue that I have with this kind of design is the fact that you only have certain areas where you can do your tie downs, and they're on the side here. So if you don't have something that spans between these 2 points and these 2 points, if it's not that wide, then you either have to move everything over to one side or the other to be able to hold it with those 2 points. But if you had something really small and you wanted to be holding it in the center, you can't really do that because, these things won't reach to that point. Now, the bigger issue that I see with something like this design is that these screws are just too high. So what would happen is, let's say you accidentally had this over a little bit. Well, when you move the entire laser forward, these stick up higher than the motor on the side here. So there's a potential that they could hit this if you didn't have this situated just right. The other thing is the laser itself. So if you were cutting or doing something else, this is higher than even the fixed focus of that. So, how we were talking about how we have the fixed focus block. Well, if you look at the fixed focus block against the screw over here, even the highest engravable section is lower than this screw. So if you were holding something all the way up in this front corner, and then let's say you wanted to go and home your machine, there's a potential that this could intersect with these screws. So there's you don't want to be hitting any of these things. So you just have to be careful that you know where your laser is at all times, and that you don't potentially run into any of these things. So, with all of those kind of somewhat downsides to using something like this, I personally prefer something like a honeycomb, where you can, set up pegs that are shallow, that won't affect any of the surface. You could also put with a honeycomb, you can put the pegs anywhere or magnets anywhere, so that you have more of a variety where you can place things. So that's just my opinion on this kind of cutting board versus something like the honeycomb. And IKIER sells both of these, by the way. They sell this one, which runs about, I believe this one's around $110, which is also seems somewhat high for something like what goes underneath the cutting surface. Because you can get those fairly cheap. So I would personally go with a honeycomb over something like this design. So for my overall thoughts on this machine and who would benefit from a laser like this, it really comes down to what your needs are. Like I keep saying, this is the most powerful wattage of any machine that I have. It's not the same wavelength as something as a CO2 machine, so it will never be able to cut clear plastics no matter how powerful it is, or deep into metal like a fiber laser. But if your primary concern is cutting out wood and opaque acrylics, then this has done it faster than any other machine I've tried. If you are more interested in fine detail engraving, then a lower wattage machine will give you a smaller spot size and increase your resolution. While the 35-watt switch does help with the resolution, the big draw to this machine is the power while cutting. I mentioned earlier in the review how I would like to see some improvements to the enclosure to make it more effective in fume retention and exhausting, but some of that can be added by the user already. I still highly recommend an enclosure, especially for a machine of this type of power. So that's it. I wanted to thank IKIER for providing me with this machine for my honest review. And again, there are affiliate links in the video description that do help out the channel if you decide to use them. Either way, I hope you found this review helpful. And if you did, I'd be grateful if you would give this video a thumbs up, drop a comment, or consider subscribing to the channel for more content on laser engravers, 3D printing, injection molding, and all things Maker. Thanks again, stay safe, and we'll see you next time.